Hello everyone. So in this video we are going to check if some function is a PDF or not, and obviously in the last video we had talked about how to check a function is PDF or not, what are continuous random variables, and we saw that a continuous random variables takes values in a continuous interval like 0 to 1, like A to B and something like that, right? So here I have already prepared a slide for this video to check if some functions are continuous or some functions are a PDF or not, and how to check them. And the examples that I have tried to take are from special distributions. So this video would be completely devoted to the fact that we will be trying to find how to check if a function is a PDF or not. And well, I'll just write down the conditions here, because just to check if you want to do it on your own, you might need these conditions. So number 1 would be f of x is greater than or equal to 0, and number 2 would be integral over all r f of x dx should be equals to 1. These are the two conditions that need to be satisfied in order for a function to be a PDF. Now we see that example 1 tells us that given f of x equals to lambda of e to the power minus lambda x. So lambda here is just a constant, and e to the power minus lambda x is a function of x, and it's an exponential function. We also write this as lambda into x of minus lambda x. So notice this different kind of representation for the exponential function. You might see it a lot in case of probability distributions and probability courses, even in maths in general. So this is another representation for the exponential function, right? So, and the constraint on x is basically x is greater than 0. So it simply means that x is a real number and x is positive, so it can take any value which is greater than 0. We need to check if this function is a PDF or not. Okay, so solution: firstly, lambda is greater than 0 and x is greater than 0, right? Now when two positive quantities are multiplied together, we know that lambda into x will also be greater than 0, right? So lambda into x is also greater than 0, and this means that e to the power minus lambda x would be greater than 0. This is because e to the power lambda x would be greater than 0, and the reciprocal of a positive quantity is also greater than 0, which is basically e to the power minus lambda x is greater than 0, right? So this is a easier way to prove that the PDF is non-negative by using the property of the exponential function, that it is basically never negative in case the argument is a real number. Well, in case of complex numbers, the situation might be a bit different, because you can have all kinds of numbers as you want, because a complex equation always has a solution. That is the fact here. Anyways, so the PDF f of x equals to lambda into e to the power minus lambda x is greater than 0. So non-negativity is satisfied. Right, now we see that the region of integration is x greater than 0, and I have already wrote that this means x greater than x belongs to 0 to infinity. Now to explain this, if you consider the grid where this intersection means 0 comma 0, so what we do mean is that the integration region is this, where x is greater than 0. So all of this right hand side, because you see the line, the intersection of the horizontal line with the vertical line being the y-axis, to the left of it every number is less than 0, and to the right of it every number is greater than 0, at least the x coordinate, and the center is at the bottom, at the middle of it, which is 0 comma 0, right, which is the origin. So what we are doing is we are integrating over all x which is greater than 0, and obviously in case we can never find a good upper bound, that is why we use the term infinity here, right? So well, the concept of infinity is something we should intuitively understand, and in mathematics it has a symbol, but obviously it means large enough, very large, because we can never actually denote what is infinity, but we can always say it is larger than what you think it is. That's the only way to define it. Whatever number you can think of, it's larger than that, and it will always be larger than that. That is how infinity will be defined. Now the total probability thus will be integral over the real line f of x dx, right? Now the real line basically means minus infinity to plus infinity. This is how the real line works in one dimension. If it were a two-dimensional one, what we would say is minus infinity to plus infinity and a Cartesian product of minus infinity to plus infinity. So like basically that's how real numbers work as an interval. Okay, so integral over the real line f of x dx, this would mean that we are integrating over minus infinity to plus infinity, right? And minus infinity to 0 f of x dx plus 0 to infinity, this would be infinity f of x dx. So what we are doing here is we are basically dividing the region. So what we are doing is we are dividing the region minus infinity to plus infinity in the region minus infinity to 0 union 0 to infinity. And you understand this from the set theory, which we have learned that this is quite possible. We can have a disjoint union of a set. So this set has been partitioned into two partitions where both of them are disjoint obviously, and they together make up the whole set. Well, that being said, we understand that minus infinity to 0 f of x dx plus 0 to infinity f of x dx, and since the function f of x is something like this, at the actual definition whenever you shall find it would be something like this: lambda into e to the power minus lambda x when x is greater than 0 and 0 otherwise. Well, whenever a function is not defined somewhere, it is considered to be 0. Okay, and in general, for any probability distribution outside of its interval, the function is or the PDF is always 0. Just consider it as a fact. Okay, so naturally, since in minus infinity to 0 the function f is not defined, so the answer here would basically be 0, because you are integrating something which is identically equal to 0, right? So there is no point in adding a bunch of zeros or maybe infinitely many zeros, because you know that is 0. And integration is basically a form of adding infinitesimally small pieces of the function together with the small element, right? But the function itself here is 0. So it's like calculating the area of a rectangle of height 0 or breadth 0, right? So you understand how that would make sense, that the area is 0 itself. So this evaluates simply to that the real number integration of f of x dx is basically 0 to infinity f of x dx, and this would give us 0 to infinity f of x dx would be equal to 0 to infinity lambda into e to the power minus lambda x dx, and this was where we put the function in. And now since lambda is a constant and we can show that lambda is independent of x because it is already given, which means that ddx of lambda should be 0. This is the condition which makes it a constant in terms of x at least. It can be a function of y because we do not care as long as y is not a function of x. So what we mean is that lambda is independent of x, and when that happens we can take lambda out as a constant. In this case lambda is just a real number which is independent of any variable. So we took lambda out and we are only integrating over 0 to infinity e to the power minus lambda x dx. Now the antiderivative for e to the power minus lambda x, if you remember that e to the power ax has an dx has an antiderivative of 1 by a e to the power ax, right? So if you put in minus lambda here, this would become exactly this, and for that reason, what we see is that the antiderivative became minus e to the power minus lambda x by lambda, and the limits were from 0 to infinity, right? And there is a lambda outside as well, and we know how to evaluate this antiderivative in its limits. We first put the upper limit and then we put the lower limit, right? But since we see there is a minus here, what we can do is we can first put the lower limit and then subtract from it the upper limit, because since there is a minus, it will be reversed anyway. So what we do get is lambda by lambda, because this lambda would be common everywhere, which cuts off to 1 because lambda is greater than 0. And here we have e to the power minus 0x minus e to the power minus infinity, and since e to the power infinity is equals to infinity, or rather we say that limit x tends to plus infinity, e to the power x is positive infinity. So this also means that limit x tends to positive infinity, e to the power minus x is also 0. So this is something you should remember, and that is why e to the power minus infinity is 0 and the answer is 1, which proves that f of x is indeed a PDF. Now how to define it in a normal way, how to write that x is a PDF, and since it's a special distribution, so if x is an RV means random variable, and set to follow the PDF f of x was as defined as in the above case, which is lambda into e to the power minus lambda x for all x greater than 0. Then x is called exponentially distributed. So what x is basically exponentially distributed, or it is following a distribution called exponential distribution. We shall learn more about this distribution and other related distributions later on in the course, but for now the name should suffice. And the parameter which it follows with is called lambda, and it is said that x, and this symbol here basically means that x follows, right? So x follows, or x is distributed with the PDF of exponential of lambda, exp of lambda, while the PDF is basically f of x equals to lambda into e to the power minus x, right? This is how it goes, right? So that should be it for this video, and this whole lecture was basically on focusing if we can find a few PDFs or not. From the next lecture we shall define about expectations, higher moments, MGFs and stuff like that, and then we shall move on to special distributions. Thank you for watching. So please download the Breatter Maths app, which is given in the description. It is a mathematical app where you can find all the necessary statistical calculators like chi-square calculator, one variable means, population means, t-value, and much more. You can also find calculus related calculators like integration, derivatives. There is a section where you can find what's coming up next. There is a section completely devoted on mathematical notes, where you can find notes on probability, statistics, calculus, and many more are there to come. In those notes we have already explained all the examples, all the problems and theory, and we are just covering the video lessons and solutions of those here. You can check that out. Also you can see the video solutions in a separate section where you can understand and give a feedback on what to expect next. You can ask for a problem, you can ask for a theory section as well. So please do check it out, and also do subscribe to Breatter Maths app and also its YouTube channel.